All right, so what we're going to work through in this video is a percent yield problem. But in order to do percent yield, you have to find something known as the theoretical yield. Now, before you go through and you're like, theoretical yield, how do we do that? Well, here's the thing. You've been calculating the theoretical yield. Every time you do a mass to mass stoichiometry calculation, that's what you're finding. All right. So the theoretical yield is how much is expected to be formed. All right. If you have X amount of reactant, you expect to get Y amount of the product. But things don't always work out 100%. Okay. And so in a laboratory setting, the amount of product that you get is known as the actual yield. And so to find the percent yield for a reaction, what we're going to do is we're going to take the actual divided by the theoretical and multiply that by 100. Okay, so let's look at our problem that we have up here and how this will lead us through doing all of these calculations. All right, it says when nitrogen and hydrogen react, they form ammonia gas, which has the formula NH3. So we're going to write the formulas and balance the equation. So here we go. We have nitrogen, which is one of the 7 diatomic elements, so it's written as N2. Hydrogen is one of them as well, so that's why we have H2. And then the formula for ammonia is NH3. Now, as written, this equation is not balanced, okay? If I put a 2 here, that gives me 2 nitrogens, but now I have 6 hydrogens. My nitrogens are balanced, but if I put a 3 in front of here, now my hydrogens are balanced as well. So now the equation is balanced. Okay, so part A is done, and I'm going to check that off. And I'm also going to slide the paper up a little bit. If 56 grams of nitrogen are used in a reaction, how many grams of ammonia are produced? So I'm going to identify my given. It's my 56 grams of nitrogen. My wanted is grams of ammonia. So what I am working is a mass to mass. So I'm going to go from mass of nitrogen to mass of ammonia. Okay, so this is type 4 mass to mass problem. And so what I need to do first is take my given amount of nitrogen, which is 56 grams. Okay, I'm going to convert that to moles of nitrogen by dividing by the molar mass. All right, and there's 2 N's, so that's why it's 28.014. That will give me moles of nitrogen. Okay, and then from there, I'm going to convert moles of nitrogen to moles of ammonia by multiplying by the mole ratio. It's always going to be what you want goes on top, and what you're given goes on the bottom. The numbers come from your coefficients in your balanced equation. So there's a 2 and a 1. 2 right here, no number, understood, 1 there. And then I'm going to multiply by the molar mass of my wanted, which is 17.031 grams per mole. Okay, so this step, like I put earlier, gives me moles of nitrogen. This is how I convert and get moles of ammonia. And this is how I convert to get the mass of ammonia. Okay, so at this point, I just put all of this stuff in my calculator. 56, 2 over 1, times 17.031, 68.1 grams of ammonia. Okay, so this is my theoretical yield. What you calculate in a stoichiometric calculation, that's your theoretical yield. So every time you have to do the math, you're finding the theoretical yield. All right. Now, if I'm going to check off, all right, that part is done. Okay. Looking at C, it says, well, if 65.9 grams of ammonia are actually produced, okay, that's your actual yield. What is the percent yield? So now I need to use this formula here. All right. So I plug the things in. How much did you actually get? 65, make sure you guys can see this, 0.9 grams. How much should you have gotten theoretically? 68.1 grams. Okay, multiply that by 100. So 65.9 divided by 68.1 times 100 gives you 96.8 grams. That is your, no, not grams, percent. That is your percent yield, okay? 96.8%. All right, so if you have any questions, if you're one of my in-person students, you can just ask me and I will help you. If not, you could just comment below and I will get back to you as soon as I can.